Good afternoon, ladies and gentlemen. Thanks for taking the time to see my humble presentation today. I would like to first of all thank Fabio Akita for changing my slot last minute. I had a few issues with my travel arrangements. And also because he appropriated CodeMiner funds last year to create a presentation that had essentially the same production values as Infinity War or Iron Man. I decided to go into a different direction here, aesthetically thinking, and think of my presentation as the IKEA of presentations. So, Swedish. A little bit about myself. I today serve as the Director of Technology at Autoscal24 GmbH. It's one of the biggest tech companies in Europe. We basically buy and sell cars, and we're building the future of transportation back in Europe. We're based in Bavaria, and if any of you are interested in moving there and working with Scala, we're hiring. I'm also an advisor at a few startups here. One of them is Blinking, which is a really awesome company in the augmented reality space and machine learning, based in Munich with a few teams back in India. And they're doing some really interesting, great work. And finally, I'm also serving as an advisor for a Los Angeles-based company called Lucidity, and also as a VP of Engineering Interim there. And we actually have a few engineers working on that project there. What's up, guys? And this company works in the blockchain space, and a lot of what you guys are going to see here today come from the work that they are doing. Awesome guys that are here doing. A big enthusiast of tech and startups and change. I believe that we as engineers and technologists and even managers, we basically build things that sell for money and they run on nothing, on electricity, and that's fucking awesome. Like, it's the closest thing to magic that there is today. All right. So the theme of my presentation today is blockchain-powered analytics. Just talking with a few of you before the presentation, it is quite interesting how blockchain is not a very well understood platform and technology today. Is closely associated with Bitcoin in most of people's minds, and you'll see throughout the conversation we're going to go into here that it's actually a lot more than that. So starting by the easy part, if you will, analytics. Like, what is analytics? A lot of you guys probably work with it every day. You probably are thinking about dashboards, about New Relic, or God forbid Excel. I believe that the simplest way to define analytics in the context that would be interesting for us here is to, like, you're getting data and you're creating value out of it. You're creating cash at the other end of this stream. So you're tracking this data somehow. You are getting this data via mobile devices, via IoT systems, via embedded JavaScript tags in hopefully secure JavaScript tags that don't do like SQL injection. But you're essentially tracking this data. This data needs to be stored somewhere, and the scale of the data that you need to store there is quite significant. We're talking about a bajillion, gigazillions of petabytes. Like, it's basically a lot of data that you need to store. And you need to analyze this data, you need to slice and dice, you need to understand what is going on with your data, because otherwise it's just entries in a log or entries in a database, and it doesn't really mean anything, doesn't really have any value until you actually apply your brains to understanding what's going on there. And finally, at the other end of this chain, you're using the knowledge that you derived from it to generate some value. This could be understanding market reports so that you can invest better. This could be detecting signals from your machines to determine whether you need to take some action there, like a server is going down and an application is on fire. Your engineers, and most of your engineers, and I believe that I'm speaking to the right audience here. Now, for those of you who know a little bit of game theory, you know that like outcomes of reality tend to go towards the incentives of your game. And in life, you have different players that have different incentives. Like everybody's trying to do something, everybody's trying to win. And a lot of times, these incentives are not going to be the incentives that take you towards the outcomes that you're seeking there. The stakes are incredibly high, so the GWP, essentially the sum of everything that is being produced in the world last year is $80 trillion. A lot of it being trafficked digitally somehow and analyzed and understood, and you have people making data-driven decisions to move this money around. The scale there is large any way you look at it. You're talking about lots and lots of money, essentially Google scale, and things happening at a scale that we probably can't even understand as individuals today. Just as an example here, like the ad tech industry, you have like a bajillion requests per second happening at all times. Even with single companies, you're talking about hundreds of thousands of requests being processed every second at speeds of a few tens of milliseconds. And although the SLAs are not as high as our friend who works with telephony over there, you don't need 9 nines to work with that. It's still money that is exchanging hands there. So you need to do a really good job in making sure that this works. And trust is a very, very hard thing to enforce. And if you have essentially the entire economy of the world being powered by data and people making decisions about how to move this money around using data, even in the most basic forms, trust is an incredibly important thing. Because without trust, society and commerce breaks down essentially. Which brings me to the next topic, blockchain. A lot of you probably think about Bitcoin when I mention blockchain, right? The thing that has been on the news for the longest time, and it has grown incredibly fast in the last 5 or 6 years, and it's just the thing that most people equate with the blockchain. But blockchain is actually a lot more. And the main problem that the blockchain aims to solve is that of trust. So let's start from the premise that trust lies at the center of most human interactions. So if you need to buy something, if you are learning something, if you're working with someone in your day-to-day job, there is a component of trust that even if you're not paying attention to it, it is built into that interaction. If someone is telling you that there's a problem, or if someone is giving you information that you need to take action on, you're trusting that person to a certain extent for that information to be correct. So how does trust work today on a pre-blockchain world? Well, the first type of trust is personal reputation, right? Like you look at this guy, like it could be your uncle, could be a family member that you're trusting him because he's your uncle. It could be like the successful businessman, like he probably is. He's wearing at least 4 layers of clothing, which instantly makes him trustworthy. Or it could be a politician, at which case, like perhaps trust is not that applicable there. You can also have, and this is probably one of the most common sources of trust that you're going to use in your day-to-day, trusted intermediaries. So most common intermediaries you're going to work with are like banks. The bank is an intermediary you trust to take care of your money, right? Like you use your credit card, you receive your money in that intermediary, and everything works hunky dory until 2008, of course. So if you look at this picture, there's multiple intermediaries there. Like you have obviously Lehman Brothers, which everyone trusted inherently right up to 2008. And you have Christie's, which is the auction house, or possibly these two guys bought the Lehman Brothers sign to put on their frat house. And people trusted Christie's to verify that the authenticity of that piece was correct and verify the money that people paid for that piece of, I'm not gonna say shit. And you have like data. You have data per se. So most types of transactions that have any value for you are going to be stored in a ledger. They're going to be stored in a notebook, in a log, into something. And most types of ledgers today, if not all, they're not super trustworthy sources of information. Like this is a ship's log, and the guy was like doodling instead of logging movements of the ship. And he could be changing entries there. He could be incorrectly logging speed of the wind or the position of the boat. He could be smuggling cargo, and none would be the wiser. So, what is like? How does blockchain solve that problem? You can think of it as essentially trust 2.0. If you look at the blockchain really, if you really deep dive at what it means, it is an immutable, tamper evident distributed ledger of linked blocks of information and operations that can be independently verified by consensus in a network of trustless operators. Like, this sounds like a lot to take in. So let's deconstruct that a little bit. First, it is immutable in the sense that the very construction of a blockchain ledger implies that you are storing entries in that ledger in a sequential fashion, and if you were to tamper with any entries of that ledger, you can cryptographically check that this information has been tampered with. So everyone has a copy of this ledger, at least in the most common implementations of blockchain, and they can verify mathematically beyond any shadow of a doubt that block is correct or has been tampered with. It is inherent to the construction of the blockchain ledger. And all operations can be independently verified by a network of like people who have a financial stake into verifying such operations, just by the very design of the technology. As I said before, you can use cryptography. It's built in the very core of this technology that enables like independent operators to make sure that everybody is playing to the rules inside of your blockchain. There are different ways of making this verification. It depends on the actual implementation of the technology, as you will see a little bit later. But this is the real value that blockchain is giving us. It's a way of building trust that can be mathematically verified at scale. So here are a few players, current players in the world of blockchain. First of all, you have the granddaddy of real world blockchain operations today, Bitcoin. Bitcoin is essentially a network that allows you to use coins to buy stuff. It is a proof of work system, which means that you have networks of computers actively mining and executing, like solving cryptographic problems to provide the juice that allows you to verify transactions and create coins. Interesting fact: the total energy necessary to mine all Bitcoin today can power Hungary. So it's a lot of energy that goes into using Bitcoin. As you can see, and if you need more and more coins to continue growing the network, and if you need more and more power to verify transactions, this is not really a great sustainable state to deliver on the mission of Bitcoin, which is to create peer-to-peer, fully distributed, tamper-free basis for an economy. After that, you have Archain, which is a relatively new project. I had the pleasure of going to Berlin to watch its release. It was quite interesting when you were in an audience where someone shares a terminal screen and puts a bunch of codes there, and press enter and like, hey guys, the test net is live, and everybody claps in the room. Definitely not a room full of investors there, but that was super cool because our chain, as many of these projects here, is not actually a company, is a cooperative that is governed by a number of partners that aims to create a platform for people to develop applications on top of it, and it has many interesting, desirable qualities to it. You have Ripple, and I put it here mainly because it's a cryptocurrency XRP. For some reason, hiked 40% in value recently, and I think that this was a really good example of what is going on in blockchain today. There's so much going on that people don't really understand the value behind things that are happening in this space, and it's difficult to track a specific movement in adoption or valuation of say XRP to something that is truly generating tangible value behind it. Which brings me to Block One. That company has, I believe, the highest seed round raise of any tech company in the world without having any product whatsoever. They raised $4 billion a few months ago. Think of it like when you start your company, you guys are like laboring to launch your MVP. This guy's got $4 billion without actually having a product to go with. Yeah. And last but not least is Ethereum. Ethereum is a technology that I'll be focusing a little bit more in today as the basis for the explanations I'll do. And Ethereum is a blockchain-based platform for you to write distributed apps. So it does have a currency to it, but that's not the main thing that makes it interesting. You can actually write applications that run on top of that blockchain, and by the use of the trustless mechanisms that this blockchain creates, it can operate in ways that everyone involved in the transaction can independently verify it. Come back. There you go. Can independently verify it, which is quite interesting for the case of analytics, as we'll see in a minute. Boom. So let's do a crash course Ethereum for like explain to me as if I was 5 years old. For the experts in the room, like I'm sure that this is super basic. We don't need to go into the details of every single point of Ethereum because otherwise we'll be here for a month. But these are things that I think connect really well with the mission of powering analytics by Ethereum. First, as I said before, it's an open source blockchain-based platform for distributed applications, which people call dApps. One more term for you to remember. All operations within Ethereum are described by smart contracts, and they're primarily written in Solidity. Solidity is a programming language created by the creator of Ethereum that helps you like write smart contracts that work in the way that they are intended to. And they determine what should happen when things happen. So when there are specific triggers, a signal coming from a device, a signal coming from an API, or coming from another smart contract that is going to trigger a change of state in your smart contract. And they're essentially the stuff that runs. So the stuff that is running on the Ethereum blockchain is primarily your smart contracts. The Ethereum virtual machine, the EVM, is the distributed magical virtual machine in the sky that runs that stuff, that is going to run your smart contracts and the basis for your applications. Ether, which is the crypto fuel or cryptocurrency that pays for stuff to run. So every time you run your smart contracts on the Ethereum virtual machine, that has a computational cost that is ultimately transacted to in Ether. So just to give an idea, an Ether equals 10 to the 18th way, and the unit of measurements that you're going to see a lot when working with the blockchain is gigaweight. That's usually the unit that most smart contracts operate at. So smart contracts executions fees are called gas. So gas is a way to determining the cost of runtime of a smart contract. So every time you need to run an operation, imagine like you're getting a web request to your API. That would be an operation powered by a smart contract. That smart contract is going to be running the EVM, and the complexity of that smart contract, like it has a number of bytecode operations, is going to be summed up, and that works out at the end to a certain amount of weight, a certain amount of computational energy that needs to be used to running this smart contract. And it doesn't matter where this is running. Like, this is super cool because it's running somewhere. You don't care about where it's running. Like, it's running, and you're paying for the computational power that goes in it. And I put proof of stake here because Ethereum is going the direction of proof of stake, and that is such an important point. It's not there yet today. It currently operates in a proof of work system similar to Bitcoin's, but we are promised that in a few months it is going to be operating in a proof of stake system. And then the cool thing about proof of stake system is that you don't need the energy equivalent of a medium-sized country to power your economy. The way that this works is that validators, not miners, they pay to have a right to validate transactions. And when they validate transactions, they receive a certain amount of cash for it, a certain amount of Ethereum for it. And the energy necessary to validate these transactions is a teeny fraction of the energy necessary to mine a block in Bitcoin. So we could actually have a small machine running a server somewhere that is a huge validator. Like you're working for a huge company, and that same machine is your validator. You wouldn't need to have a ginormous amount of ASICs, specialized circuits, running somewhere in China to say that you're working with Bitcoin. So this is what actually makes Ethereum and other systems that implement proof of stake so interesting for the future of blockchain. Cool. So what is the first thing that people did with blockchain, with like such cool technology? Like, of course, they built something that has to do with cats. Like, of course. And this is one of the first very publicly available applications built on top of Ethereum. It's called CryptoKitties, and it allows you to create virtual cats and nurture them and prove that you own them because it runs on the blockchain. And perhaps a more interesting application there is Lucidity, the company that I told you guys about. And what they're doing is that they are applying the technology of the blockchain technology of Ethereum to solve a very, very real problem in the industry today. And this problem is quite similar to other industries. The problem that they're solving here is that when you run ads online, there are many people involved in the buying and selling and tracking and managing of that single slot, and all these guys have different incentives. So some of those guys want numbers to go up. Some of those people want numbers to go down. Some of those people want numbers to be changed in a certain way. And what ends up happening in traditional ad tech is that it takes 90 days for money to exchange hands. It is an incredibly high attrition process, and it has spawned an industry the size of $16 billion per year just to check the guys who are checking whether impressions are being correctly tracked. It's crazy. And you could apply this line of thinking really to let's say you want to build an application that allows you to pay in a single system to read articles from whatever source you want, so that you never have to see a paywall in Flipboard again. Let's say you want to build an application that allows artists to sell their songs, their song plays, without going through any particular like intermediator like Spotify. You could have companies building what essentially are front ends to blockchain, and this money is going directly to the artist after the front end takes a fee. So there are many situations where you have a need for distributed analytics at scale, that you can verify by multiple parties what is actually going on there, and especially in situations where there are such different intents, such different incentives for people to want numbers to go one way or another. So great, like we can do this with Ethereum. You can write a smart contract that triggers impressions, clicks, and everything at the right times, and everyone can verify them independently. Problem solved, right? Let's go home. Problem solved. Like you can do that for whatever you want. Yeah, not really. So first, Ethereum operates at 10-ish transactions per second on a good day, maybe a little bit more, maybe a little bit less. If AdTech alone operates at millions of requests per second, you guys can see that there's a problem there. In any other industry that requires distributed analytics to work in such a fashion, such as music, Netflix, like content management applications, you're going to run into the same problem. And you likely, even on a small application such as a game, if you want to use it, if you want to use blockchain to power your game's economy or your game's analytics, you will need a lot more than 10 transactions per second. Cool, and that's where Plasma comes into play. So Plasma is essentially a way for you to build side chain, a chain that is attached to your main chain. And it describes a way where you can verifiably track things independently in your side chain at a very, very high throughput, and commit to the mainnet, like Ethereum, at a certain interval. So in this case, for instance, you can have your sidechain tracking impressions or clicks at millions of requests per second, hundreds of thousands of requests per second, like whatever it is that you need. And you're only committing to Ethereum mainnet, say, once an hour or once every few minutes. You're committing the map-reduced bulk of the operations you're performing in your sidechain, and that makes it possible for you to like actually write applications that operate at the scale. Many of us need those applications to operate with the blockchain, and is to get all the nice benefits that you get with the blockchain. Like everyone can independently verify it, everyone can check the sequence of events, and this is running on a platform much like the internet. Like it doesn't necessarily belong to any particular company. And the benefit, for instance, for Lucidity's customers is that instead of waiting 90 days and going through an incredibly high friction problem, they get paid every day, and they get paid like the money that everyone agrees that everyone is owed. And this can be true for anyone who would decide to build an analytics-intensive application on top of a blockchain substrate. And companies are free to implement the side chains in ways that benefits their domain. So you can create your side chain, and you can set the rules of that game to create the right incentives for the problem you're trying to solve. Like in case of ad tech, you want to make sure that everyone has the same common understanding of what an impression is, of what a click is, of what a win is, or any other relevant events there. And because everyone has the same understanding of what those things are and how they should be tracked and how they should be triggered, the numbers coalesce at the end, and everybody wins. Cool. So just a quick summary. I realize that I'm gonna end significantly earlier here, but first thing, if there's one thing that you take from this presentation, like just the one thing, is that blockchain is about trust. The problem that they solve is trust. The second is that if you choose to build an application that uses the blockchain, check out Ethereum. It's pretty solid technology being actively developed. There are many quite significant applications running on top of it. And you'll be greeted by a very active and engaging developer community there. Third, you likely will need to learn how to use Plasma or any other of the available technologies necessary to actually build things that scale to the analytics use case on the blockchain. So you might as well start looking into it. And analytics love blockchains. If you think about it, even traditional applications where you just need to show a report, if you ever had a customer asking you for a report, using a system such as this mostly eliminates that problem. And this coming arguably from the worst industry where people asking for reports reside. So if you ever had such a problem, you might want to start looking into this. And last, you had the economy is worth $80 trillion. The traditional trust models that we have today, they have shown signs of stress and cracking at many points, like 2008, the big problem that existed there. So I might as well start looking into ways of improving it and making it more transparent and precise. Thanks.